So let's talk about this. Let me put a couple matrices up here. Alright, so here we've got our matrices. And now we are going to, now we're on a scrap piece of paper, a new sheet of paper, some notes somewhere. We're doing some review to make sure everybody's got this under control. Alright, so here's some given. Those matrices are given. Let's see if you remember what all this means. See how many of these questions you can answer. One more. You're on a scrap piece of paper or a note sheet, some kind of piece of paper somewhere. You've written down these three matrices, and you're seeing how many of these questions, there's 6 questions, how many of those can you answer? So we'll take a minute and let everybody catch up. Come on. We'll let everybody catch up, and then we'll go from there. Did anybody remember the first one? What does that mean?
Second row, first.
It's second row, first column. I'm looking for a number. Second row, first column in matrix C. So second row, first column would be 0. How many said 0 for that one? All right, you are awesome. If you didn't say 0, do you understand why the answer is 0? Kids? All right, anybody get number 2 right, do you think? Taylor? 2 by 3. There are 2 rows and 3 columns. Somebody, 6th period on Friday, was getting all confused, and Maya Meredith said, bleachers have rows, White House has columns. So if you're getting them confused, rows like bleachers, columns like the White House. All right, anybody get an answer to number 3? It's a matrix. Taylor?
2, 3, 3, 7.
She is exactly right. Anybody have a question about where any of those numbers came from? She is exactly perfect.
How did you do that?
If you have been absent, you need to watch the videos because it's all done on video, okay? But basically, she added first and first, second and second, third and third, and fourth and fourth. She added corresponding entries. That's how we add matrices. Number 4. Anybody get that one? Taylor?
You can't do it.
You can't do it. And why can you not do number 4, Taylor?
Dimensions are different.
The dimensions are different. And the rule for addition is if you're going to add them, they have to be the same size. Because of the way we add, they have to have numbers in the same spots. If they have extra numbers or numbers in the wrong spots, you can't add them. Alright, 5, this is the hardest one. It's not hard, you just have to stay organized. We are multiplying A times C. I don't need this anymore, so I'm going to erase that. Alright, what are the dimensions of A? 2 by 2. 2 rows, 2 columns. How about C?
2 by 2.
2 by 3. Now the rule for multiplication is those two numbers have to match. And they do. So we can multiply. The answer that I get, which I'm going to write up here because I'm out of room over there. The answer that I get will be a 2 by 3. The inside numbers match. The answer will be the outside numbers. Which means I'm going to have 2 rows and 3 columns. To find this number, I gotta find all of them. I'll start with this one. It is in which row?
1,
Which column?
2,
Which column?
1.
So it is in row 1, column 1. So I am going to multiply row 1 times column 1. How many numbers are in row 1? How many numbers are in row 2, or column 1? 2. So I multiply first times first, second times second. So I multiply 1 times 1, 2 times 0, and add them up. What do I get when I take first times first, second times second, and add them up? What do I get? 1. That goes right here. I gotta find all of them. It doesn't matter the order you do it. I'll find this one next. I mean, it doesn't matter. All right, where's that number? What is that? Which row? Row 1, column 2. So now I do exactly the same thing, but I multiply the numbers in row 1 times the numbers in column 2. So 1 times negative 1, 1 times negative 1, and 2 times 3. What do I get when I take 1 times negative 1 and 2 times 3? What do I get? 5. 5. All right, fill in the rest of them. See if you can fill in the rest of them. Work your way through. Take each row times each column. Are we matching so far? Are you getting the same things I'm getting? if I randomly made up two matrices, would I automatically be able to multiply them? No. What's the rule? The inside dimensions have to match. What's the rule for adding? The dimensions have to match, period. So an 8 by 5 and an 8 by 5. Okay, 2b, what does that mean? 2b. 2 times b, which means 2 times everything in b. So that would be 2206. Someone impress me. What is the fancy word we give to that number? It is a coefficient, but what is the matrix word we give to that vocabulary word? Scalar. That's in your vocab list. It's a scalar. Okay, now we got to get through a little bit of new material, but at the end of the period, I'm going to give you this kind of thing again as a practice, because tomorrow we're going to be able to do this. Look at this right here, okay? But first, get your note sheets out. Let's go through our lesson. It's easy. We are on page 45, number 3.
So you would just plug that in.
Isn't it? Normally my matrices have like brackets, right? Notice that this notation is like more like absolute value. This notation tells me that I am finding the determinant. The determinant. And the determinant is just a single number. So this is going to be a number. Here is the number it's going to be. -2. Now, I showed my work. Can you figure out what I did? I multiplied 1 times 4. I multiplied 3 times 2. And then what did I do with those numbers? Subtracted them. That's it. That is all there is to it. So let's look at the next example. Now again, it's just going to be a number. This is going to equal a number. So what number is it going to equal? 2 times 7 minus 3 times -1. You've got to be real careful about your signs here. What does that equal? 17. Everybody understand why 17 and not 11? You got a double negative, that means add, right?
Right.
Do that one by yourself. What'd you come up with? These sign issues again, we have to be careful. We should have gotten -11 because we have -3 minus 8. You have to watch your arithmetic. Everybody okay?
So we subtract them, right?
Mm-hmm. Yep, this brings back horrible memories for Mrs. Ford because I failed 2 quizzes in my life, and one of them, you have an English major and a math major, and one of them was in English and one of them was in math. The one in English I failed because I didn't do the reading. My teacher had assigned the celebrated jumping frog of Flabush County, and I did not read it, and so I failed that quiz. She was so disappointed in me. And then we had a quiz over determinants when I took this class, and for some reason, I do not know why, instead of multiplying and subtracting, I subtracted and multiplied every problem and got an F.
But it's only doable.
It has scarred me for life. So please remember that we multiply, cross multiply. Somebody said it earlier, cross multiply. Remember that, you'll remember cross multiply and then subtract. All right, this guy is a little bit bigger. We can only do determinants if the matrix is square. So we started with 2 by 2s,
Right.
and now we're moving to a
3 by 3.
3 by 3. You can't find a determinant unless the matrix is square. So the next step is a 3 by 3. Okay? Now, here's how this works. I want you to take the first 2 columns and recopy them right next to the determinant. Have you done this before? Does it look familiar? I don't know how much you paid last year. So we're taking the first 2 columns, being very careful to make sure you got the negatives in the right spot and everything. Copy your 2 columns. All right? Now, I want you to take these 3 numbers and multiply them together. So what do we get if we multiply those 3 numbers? -1. Now I want you to multiply these 3.
These 2.
Oh.
Multiply them together. What do you get?
6.
And then multiply these 3.
0.
0. Now add them up. 5. And you're not done. Because now you're going to multiply these 3.
0.
0. And then you guessed it, these 3.
2.
You're multiplying. And these 3.
2.
You're multiplying.
Oh, I didn't pay attention.
And add those up. Now, I want you to think about, in your 2 by 2s, you took this minus this, right? So, this totaled 5, this totaled -6. What do you think I'm going to do with those 2 numbers? Subtract them. So 5 minus -6 gives me a determinant value of 11.
What about the 0 and the -1?
Well, that 0 is used there, and that -1 is used there, so they're used. They're just not, those particular pieces of them aren't used. They're used in other places. lousy woo-woo. Let's try another one. Here's the next one. All right, you remember step one.
Rewrite the first two.
Rewrite the first two columns. So -1, -2, 2, 4, 1. Now we're going to do some multiplication, remember? It's important you start in the right spot. Start at the beginning. This is the beginning. This is where we start. So we're going to multiply those three numbers together. And we're going to get what? 36. And then we're going to multiply these three together. And we get 0. And then we're going to multiply these three together. And we get 1. And what do I do with those three numbers now that I've got them all figured out? I add them up. Okay, now what? I go down here and start over. So I multiply. -8. Multiply. And multiply. Giving me a total of -2. Then I take those two answers that I got, and what do I do with them? Subtract. So 37 minus -2 would give me a value of 39. All right, you try F on your own. I'll do it up here. We'll see if we match. I got -16. You concur? So everybody's feeling okay about finding determinants? And, oh, Erica?
Like, I did 20 minus 4.
Okay. It's all, you you always do these, you always start here and do these numbers first. So 4 is what you should have gotten first, because we always start here, okay? Always, this is where we start. So that's always gonna be your top number. And it's always top minus bottom, so you just put it in reverse. Just remind yourself to start at the beginning with the very first number. Now, a question that should be in your mind is, Mrs. Ford, this is like really cool, and I get it, and it's easy, but what in the world do we have determinants for? I mean, what are they used for? So I've got a couple, there's more than that, but I have 2 ways we use determinants. So would you turn to the next page of your note sheet that I think says use Cramer's rule to solve? Yeah. Find the page that says use Cramer's rule to solve. And I'm going to show you one way we use determinants. All right, step 1. I want you to make a determinant out of the coefficients. So in other words, 2, 3, 3, negative 4. 2, 3, 3, negative 4. So what would that be? Negative 17. Everybody good? Now, believe it or not, and you're going to see how this works in a second, that number is the denominator of your values for x and y. Now, look at this. Could you do substitution or elimination on this?
Yes.
And your answer would be an ordered pair, right? An x value and a y value. Well, we're going to find x and y a little bit different way. And that negative 17 is the denominator of the values. Now, how do we find the numerators? Well, believe it or not, it's just as easy. These were your x coefficients, and these were your y coefficients, right? When you are solving for x, I want you to take out the x numbers and replace them with the constants. So in other words, instead of having 2 and 3 here, I'm going to have 1 and 2 there. And I'm still going to have 3 and negative 4. So it's this determinant, but I'm cutting this out and pasting it on the x numbers because I'm solving for x. And then when I do y, guess what I'm going to do?
Take the Y out.
I'm going to take the y's out and paste this in instead. So I'm still going to have my 2 and 3, but now this is going to be 1 and 2. Now I'm going to evaluate these. Here we go. What's this numerator? Watch it. Isn't it negative 10 over negative 17, which is 10 17? And what about this one? 1. So the answer to the question is 10/17 negative 1/17. Now, all of your substitution and elimination problems I rigged so that you got answers like 2,3. Oh, because I want you to think about this for a minute. If you solved using substitution, let's say, and you got x equals 2, what was your next step? Plug it back in. So I made sure that you had nice, neat numbers when you plug back in so that you didn't have to worry about fractions and all that stuff, right? Most of the problems in the world aren't rigged, of course, and you get these hideous, horrible answers. Well, let's think about it for a minute. Did it really matter to me that those were fractions? Did I have to do anything with those? Did I have to do any arithmetic with those? No. The beauty of Cramer's rule is the arithmetic is easy. You never have to worry about plugging back in and working anything out. The answers can be as hideous as we want, doesn't matter. Let's try the next one. We're going to stop and review here in a second, but let's get through another one. Let's see if you remember the steps. We're going to solve using Cramer's rule. Step 1. Build a determinant out of the coefficients, and they have to be lined up. You have to have x, x, y, y. Everybody okay with that? What is the value of that? -3? -1 minus 2. All right. Who remembers what we do with the -3? That becomes, remember, we're solving for x and y. And that -3 becomes our denominator. What is our numerator? Well, we're going to have new determinants, right? This is the tricky part. Do you remember what to do? We take the 7 and the 8, and if we're solving for x, we put them right here. These are the x numbers. So we'll have 7, 8, 1, -1. We just take the 7, 8 and glue it right here. If we're solving for y, we take the 7, 8 and glue it here. All right, what's this numerator? You got this figured out?
Excuse this interruption, please. I need all students in the basketball choir to report to the front office at this time. Once again, all students involved in the basketball choir, please report to the front office at this time. Thank you.
All right. So -7 minus 8. Did you get -15? But remember, that's divided by -3. So your x value is 5. 5. Good luck. Have fun. Sing well. And what about y? Negative 6 divided by negative 3. So your y value is 2. Could we have done that problem using substitution or elimination? Sure we could have. We did it using Cramer's rule. No arithmetic, pretty easy. All right, you want to take a break from the new stuff and look at the old stuff again, make sure you got it under control. What time's the bell ring? 30? All right, you got 6 minutes and do some review. You and your partner. Find a new partner if you need a new partner. Yeah, answer these questions. We're getting ready for a quiz. Yeah, you can do it with a partner or your own individual, whatever you want to do. We don't have much time, so I want you to work together.
What'd you say about that?
All right, take a minute. See how many of those you can get done before the bell rings.
Oh, I brought it for Ryan because my sister last week did it. Walmart gave me a whole box. Walmart.
This is a 2x2. This is a 2x3. If they're going to be added, they have to have the same dimensions. Add them, they have to have the same dimensions.
First row times the first column. That's negative 1 plus negative 1 times 0. So we do first row.
Okay, our time is almost up. I know we kind of rushed it.
Either way, I'm never gonna know.
Everybody okay with number 1? Everybody see why you can't do this one? Everybody get 2 for this one? Matrix A, second row, first column. Alright, and then the multiplication problem, which is the one that takes a while. Anybody want to talk about any of those numbers? I did it real quick, I might have made a mistake. Which one?
I just didn't get to finish that one, but I got everything else. We were on a date, should we take that quiz? Are we supposed to read makeup the quiz?
You're going to have to take the quiz, yeah, when you're ready. Let's try to get ready this morning.
Like over something. Yeah, it's
This one here?
Yeah.
Now remember when you do multiplication, you take this times this and this times this and add them.
Oh, yeah.
You're getting confused with this sign. All right, whoa. Homework. I gave you a worksheet the other day. Your job is to do part 1. On the worksheet. Part 1 on the worksheet.
Is it denominator and inverse triangle?
Yeah.
With the pen?
Yeah, it's safe with the front. Oh, it's front. Have a good day, everyone.
Good morning, my life. Conversation. I need to help you figure some things out.
Have a great day.